Alright, so this time around, instead of solving functions, we are going to be looking at pictures of functions. So you may know a function can look something like this with our y and x values and some form of line. So this would be a linear function. Because it is in a line. So this would be like any sort of function that you know, like f of x equals x plus 1. That would be a linear function. It'll always be in a straight line. Let's look at some different types of functions. Put that one away for now. Let's look at some sort of function that looks like this. Okay, so this would be an exponential function. We talked about these when we did exponents. Exponential, run out of room. Have to do with exponents. So this would be something like x squared, f of x equals x squared. So every time that x gets bigger, y gets even more bigger. So you can see when we move up on this graph, we go up one at a time. Down here, when we move up one, y doesn't go up very far. But up here, when we move up one, y goes up a lot. Okay, and the more we went, the quicker y would increase. Now let's look at some real-life examples. Functions are something that are pretty easy to represent real-life examples. So let's take a look at this one. If I want to graph how many, so let's say number of candy bars someone would buy for a certain price. So we'll put money over here. So let's say if candy bars were 25 cents, I would buy a lot of candy bars. If candy bars were a lot of money, say they were, I don't know, $1. $1, I probably wouldn't buy as many candy bars. So at 50 cents, I would buy so I can represent the number of candy bars I would buy in a function. This is just an example. It's actually not a very good example, but you can see I just graphed the number of candy bars I would buy for each price. Let's try and look at a better example. Let's look at how high an object is. Say I drop an object from 10 feet high, and this will be time. Apparently I can't write. Let's try that again. T-I-M-E, time. Okay, in seconds. So this would be like 9, 8, 7, 6, 5, 4, 3, 2, 1. In time, we'll go in quarter seconds. 0.25, this would be 1, 2. Okay, so at 0 seconds, I held it at 10 feet. After I dropped that ball at 0.25 seconds, say it's at 9 feet. 0.5 seconds, it's at 6 feet. 0.75 seconds, it's at 3 feet, and it hits the ground at 1 second. I can graph that with a line. A lot of times, you won't really be given the numbers. Instead, you'll just be given a picture of a graph. So let's look at the picture of this graph. And we can look at this graph and see, does it have a positive or negative slope? Well, from left to right, I can see the graph is kind of trending downward, and so this would be a negative slope. And the opposite would be true if I had a graph that was going up from left to right. This would be a positive slope. Let's say I threw a ball as far as I could. And when I throw that ball, I throw it in an arc. So you can actually graph that arc. And this would be the height of the ball and the time. So as you can see, as we go, when I throw the ball, it leaves my hand and it travels in an arc. And the longer the ball is in the air, it reaches a peak, and then it starts to descend back to the ground. Eventually, we know that that ball is going to hit the ground at a certain time. So what would the domain of this function be? The domain would be the amount of time from when I throw the ball to when the ball hits the ground. So that's our x values. This would be our domain. And then our range would be from the lowest point, so when it hits the ground, that's the lowest point, to the highest peak of the ball. That would be our range, the y values. Let's do an example. If you were asked to graph, let's draw a graph here. A graph of if you had a lemonade stand. So we'll call this lemonade graph. Okay, here's 0. I want you to graph the profit you would make based off the number of cups sold. So it costs you to run the lemonade stand. So if you sell 0 cups, let's say it costs you $5 to set up this lemonade stand. If you didn't sell anything, you would be $5 in the hole. So we have to start our graph below the 0. And say every cup you sell, you make $1. Pretty pricey lemonade. So every time we go over 1, we would go up $1. So the slope of this line would be 1. And I want to know when you would break even. So you would break even when that line crosses 0. So in this example, it'd be 5 cups. And obviously, the more lemonade you sold, up in this range, the more your profit would be. So all of this area here, that's your profit growing as you sell more and more cups of lemonade. So these are just a few ways you could use functions in the real world. You can use them to graph something, to explain something, and you can also take the graph of something and explain what's happening, to show trends in different things, usually something economical like this price of lemonade, how much profit you're going to make. Companies use it to find how much profit like a restaurant's going to make, or how many units sold of a certain object will yield how much profit. So a lot of real-world applications in lots of different types of functions.